And I think we're off, yeah? We're all ready to go. I think we're live and broadcasting now. So the wonders of real-time communication we've crossed over, and just to say hello and apologies for the problems earlier trying to get us hooked up, but we are up and running now. So just to introduce myself, my name is Sam Dutton. I'm a developer advocate for Google Chrome based in London, coming from London today, and yeah, we've got people from all around the world, so if we could just cross over to the others now and people could introduce themselves and see who's here.
Hi, I'm Justin Bertie.
Hi, I'm Molina Baradi.
And I'm Tommy Wiedenflykt.
And from Stockholm, I'm Serge Lachapelle.
Fantastic. It's great to see everyone here. So what we're going to do today is we're going to kind of give an overview of WebRTC and see where we are now, and talk through just very quickly the sort of basics of the technology, and then really go over the questions. We've had great questions on moderator from everyone, so thanks very much for that stuff. First, I'd just like to just give you two kind of inspirational quotes from people that I've heard. The first one is from Brendan Eich, who's kind of the inventor of JavaScript, and he says that he believes that WebRTC is a new front in the long war for an open and unencumbered web, so strong words. And another quote from Phil Edholm, blogger, who says that potentially WebRTC and HTML5 could enable the same transformation for real-time communications that the original browser did for information. So it's strong stuff, and you know, we believe that WebRTC has huge potential. So for those who are kind of new to the topic, just a very quick overview of what WebRTC actually is, and it's kind of a collection of standards for real-time, plug-in, free video, audio, and data communication. Now there are some existing services that do stuff like this, so kind of Google Talk and Skype and so on, but all of these use plugins, and you know, we believe that WebRTC can do real-time more efficiently than that. So the first question I guess people are asking is, well, what do I need to do WebRTC? Well, you're going to need a source of streaming video or audio, or in the future data. You're going to need a way to communicate that video, audio or data to other peers, and you're going to have to exchange some kind of messages between each other to initiate sessions, to close sessions, and also of course to report errors as they happen. And you're going to need to be able to exchange between peers information about media and configuration, things like resolution and format. And of course you're also going to need ways to actually let people get in touch with each other. So in terms of what WebRTC has brought to the web, in terms of APIs, we have media stream for getting streaming data. We have peer connection for communicating data. And then what we're going to be seeing implemented is data channel as a method of exchanging streaming data. So a really powerful set of APIs there. Now that's looking on the client side. If we go over to the server, you know, WebRTC real-time communication is always going to need service, you know, however simple. You need for users to be able to discover each other, users to be able to send their details to each other, and communication that can survive network glitches, and so that client applications can send, you know, data about the media they're working with, like I say, so information about resolution, format, and so on. And we also, this is very important, of course, lots of client applications are going to be behind NAT gateways, firewalls, and so on. And so WebRTC client applications are going to need to be able to communicate across those barriers. So thinking from the server side, WebRTC needs two types of server-side functionality. You need stuff to do user discovery, communication, signaling between clients, and then you need servers that can help with NAT traversal and streaming data communication. So what I would suggest is, if you haven't done so already, especially if you're new to WebRTC, is do take a look at Justin Iberti's video from Google I/O. You can find that on YouTube. So Justin Iberti's WebRTC Google I/O video, which is great stuff. And if you want to find out more about Get User Media, the sort of what you might have seen in terms of stuff for using MediaStream, take a look at HTML5 Rocks. HTML5rocks.com has a lot of great documentation about using MediaStreams, in particular, of course, Get User Media. Now, what I would also suggest is having a look initially to get your head around the idea of peer connection. And if you look at webrtc.org, you'll find some great information there. But one of the sites I would recommend just to begin looking at peer connection is webrtc-demos.appspot.com. That's webrtc-demos.appspot.com. And we will have links for these available on the site. So for the Hangout we're looking at. And then once you've understood something of peer connection, what you need to do, I think, is then move on to signaling and data communication. And a great place to start that is at rtc.appspot.com. And again, we'll put the links up for that. So just to get straight down here, we've, like I say, had some great questions from people who are coming in to see what they'd like to find out about WebRTC. So I'm just going to go over now to the questions and see what we've got on moderator, and then ask our panel of experts here. So, okay, just starting straight at the top, and I guess, Serge, I'll let you dive in and see who you think might be best to answer this. The first question is from AIDGAB, coming from Kazan. Please give some explanation about how media can be broadcast to several peers using peer connection. Are there any relays that can be used with WebRTC? I think there's a couple of questions inherent in this.
Justin, you want to take that one?
Sure. So there's a couple of ways that the basic idea of doing a multi-party communication. There's a couple of ways that we can approach this. One way is that you could create multiple peer connections, one to each participant, and create sort of what's called a mesh network. And for small conferences, this can actually work pretty well. You basically send your video and audio to every other participant, and they do the same. But as you probably have noticed, like as this gets in larger conferences, this becomes less of an efficient technique. And so this is where the fact that we're kind of working with the IETF and using standard protocols allows others to create sort of what we call middle boxes. And these middle boxes can be sort of conferencing servers that can do various things like a traditional, what they call an MCU. An MCU basically takes all the incoming video feeds, in this case from each peer connection, would composite them into a single image, and then would send it back out as basically the group video with everybody's picture and sound. And WebRTC doesn't provide this technology per se, but you can create it using, there's various, products that exist in the internet, things like Asterisk, things, other services that people are creating based on WebRTC that will be able to provide this sort of functionality. And then secondly, instead of also doing a sort of compositor, you could also think of, just things that are simple relays, that when the data comes in, it gets sort of broadcast out to all the other participants. And again, these are things that you can create using standard RTP protocols, because that's what WebRTC is built on.
Thanks very much. One thing I'd like to clear up, I think when I was first looking into WebRTC and trying to get my head around it, there was some stuff relating to the different server technologies that came up that was really new to me as a web developer. And I was wondering if one of you guys could talk us through those. So the three specific things I'm talking about, well, the ICE framework and what that consists of, and how turn servers work, and what's a stun server? How does this stuff work, and why do we need it, and how does it fit in? Where do I get one?
Okay, so it is a confusing area, and in part is because this technology, the names are kind of overloaded. So when we talk about stun, stun could be a mechanism for actually retrieving your IP address as seen by the outside world from a stun server. But it could also be the method through which you do ICE, the type of sort of connectivity check messages that you send from one side to the other are called stun messages. And sort of recognizing this, the authors of stun have they've changed kind of what the acronym that stun means over time. From being one specific thing, now it's session traversal utilities for NAT. It's kind of like a bag of different tricks. Well, anyway, so what does this mean to the developer? Well, let's back up and look at the fundamental part of the thing, that's the ICE process. And ICE is interactive connectivity establishment. And in a nutshell, what ICE involves is that the client on either side will go and retrieve as many IP addresses as they can find. Typically, this will be its local IP address, the IP address of its actual network adapter, the stun address, which is basically what the outside world sees your IP address as being. You send a ping to a stun server, and the stun server replies back with the IP address that it saw that ping come from, and that gives you your outside address. And then lastly, you can ask a turn server, which is basically a network interface in the cloud, if you will. And it's an IP address in the cloud that you can kind of access, and in some cases, this is the one you'll actually want to use. Now, as I mentioned, each client kind of retrieves these addresses, the stun, the turn, and the local address, and they send them to the other side. And then both sides basically send checks from their network interfaces to these addresses they've been provided with right here. And they figure out which ones are actually usable for sending and receiving data. And whichever one ends up being the one that works and is the most efficient is the one that's actually used for the call. So looking back at the terminology, ICE is the process through which these checks are done. Turn is the actual server that lives in the cloud that provides you with a sort of IP address in the cloud in the cases where your stun address isn't immediately usable. And there's some cases, depending on your NAT behavior, where the stun address just won't work for actual communication. And then stun is, in addition to this sort of bag of utilities that are used for making all this stuff happen, it's the type of server that's used to discover your NAT address, and it's the type of sort of connectivity check message that's sent from client to client as part of the ICE process. Does that all make sense?
Yeah, thank you, thank you. Serge, I think you've got a nice diagram up there. Should we go over to that?
Yeah, that's a great diagram.
Yeah. Can we see this? So,
right.
but maybe we could just talk through that briefly and see what's there.
So, right, I mean, this is a great diagram. It shows two peers, each behind a NAT device.
Oops, Justin, I think you got muted. Sorry.
Okay, sorry. Okay, so as I was saying, we have two peers here, each behind NAT, and then the relay server, which is also known as the turn server typically, and the stun server. And the peer contacts the stun server to learn the address of its NAT. It contacts the turn server to learn and get an IP address in the cloud. And then it shares those addresses with the remote peer through the cloud. And then they perform the connectivity checks. That part isn't shown here, but it's basically to figure out what pathway the media can actually take. And for most consumer NATs, it'll be the stun address, because the NAT basically says that the address learned from the stun server can also be used for communication. On some enterprise-grade NATs, the rules are a little different, that the address learned from the stun server can't actually be used for communication with the remote peer. And in these cases, at least one side will need to use the relay server in order to get the media from one side to the other.
Great. Oh.
That's brilliant. I guess the way I understand it, just correct me if this is wrong, so the understanding I have is that when you're using WebRTC, essentially the framework will attempt to make a direct connection between the peers, and if that fails, will revert to using a relay server. That's probably a gross simplification, but is that something like what's happening here?
Yeah, that's exactly what's right. I mean, I'd say it's a little bit even more than that, because rather than have to sort of try one thing and then only fall back and use the other thing, if it fails and have a delay associated with that, we're kind of like trying all these things in parallel. And that may mean that we use the relay connection first, and then we maybe find out later that that another connection is actually better. And in cases like that, we can get the call running as soon as possible on the first connection we have, and then maybe transition it to a more efficient connection type as the actual ICE process proceeds.
Gotcha. So it's not just about connectivity, it's about efficient connectivity and data transfer. Yeah. Okay. I'm just going to go over to the questions again, because we've got a stack of good ones here. So yeah, this is a question a lot of developers are asking from Fred in Darmstadt in Germany. When will data connections be available for developers? So I guess thinking here about data channel.
So I can answer that one. We've posted our roadmap on the Chromium blog. So if you search on the Chromium blog and for WebRTC, you'll find it there. Basically, we first want to go into Chrome stable with just audio and video. And once that's working well, we'll start cranking on the data channel things. So it's just a question of having to focus and prioritize things properly. And so we decided to go with audio and video first. And right after that, once you've seen audio and video go from behind a flag into the public Chrome, that's a good signal that we're starting to work on the data channel stuff.
Cool, cool. It's incredibly powerful. I don't know who'd like to just talk this through a bit, but data channel is going to be a whole nother set of possibilities for, I can think of all kinds of applications.
Well, absolutely. I mean, it basically changes any web application into a peer-to-peer application. And by providing a lot of great tools built in, we'll have support for unreliable and reliable data and things like flow control. We basically solve a lot of the problems that P2P apps right now have to solve themselves. So the bag of tools that we're going to be providing to web developers in like a really easy-to-use package, I think is just going to be very transformative. There's all sorts of applications that need to send a lot of data or send data with very low latency. And what they'll be able to do with this API should be incredible.
One of the questions I've had personally is people asking, what's the relationship between Websockets and WebRTC? Are these two technologies doing the same thing or something different?
Well, they're slightly different, but conceptually, they're kind of the same. They're a pipe that you want to be able to send data to somebody else, in any format. And so a WebSocket will transit a server, because it's done over HTTP and goes to a web server, whereas a data channel will go directly to another peer. Now, those kind of differences are, don't really affect the overall architecture of how you could send data. And so what we've done is we've created an API for the data channel that matches what the WebSocket API is syntactically. And so if you have an application that's written to use WebSockets, you should be able to transition it to use data channels extremely easily, because we've tried to keep that difference as small as possible. And in most cases, the syntax should be identical. But the real difference is that a WebSocket is always reliable. There's no support for unreliable data, and it always goes to a server. And the data channel will always go to, we'll go to a peer, although the peer could be a server. You could use data channels to talk to a server if you want to send unreliable data to a server. But it has a lot more sort of flexibility in terms of what the actual communication protocol should be because we're not having to constrain ourselves to HTTP.
Okay, thanks for that. Just going over to I don't know, a very specific question on the moderator questions here from Lorenzo Minero. He's asking, are you going to add a way to specify resolution and frame rate for an outgoing stream? Would this be a media stream property or something that would need to be adjusted via JSEP? Just before we go into that, maybe a little quick explanation about JSEP. Now, what people may have seen was the original WebKit peer connection object, and then which has become WebKit deprecated peer connection. Now, the idea of this is that the original implementation pre-JSEP, the demos that used that stuff and applications could still use that format. And now, as we move on to JSEP implementations before full standardization, that we can call those by a different name, peer connection 00 and so on. If maybe Justin would like to just tell us a little bit more about that, or maybe for Tommy.
So, if you are really interested in this, if you look at the latest editor's draft of the peer connection standard, you will see that there we have objects called media constraints. That's not the final name, but they will contain constraints that are either optional or mandatory. So you can say that I want a video that at least 320 pixels, but I really want to have 640 wide video. And that can be, those kind of specifications can be added when you create the peer connection, but also when you create your answer or you create your offer, and also when you add your stream to the peer connection. So yes, there will be complete configurability for this.
Brilliant, thanks very much. Interesting stuff. A couple of questions from Ted at Claudio, based in Poland. I guess that's Poland. But a couple of good questions. Firstly, asking, do you plan to add an ability to transmit multiple streams using a single peer connection? I'm thinking about a conferencing server built using WebRTC library that will use single peer connection per participant. Who would like to take that?
I can speak to that one. You know, we've got the add stream API where you can basically add a stream to a peer connection, but there's you know, obviously no reason why you couldn't add more than one stream. And especially on the remote side, you could have, you know, the remote side, if you have some conferencing server, add multiple streams to your incoming peer connection, and you'd be notified as to each one of these streams. And the mechanism through which this is done is, you know, we're thinking that, you know, within a given RTP session that's on a peer connection, you could have what we call multiple SSRCs. And an SSRC sort of corresponds to like a media stream track, and then tracks, as you know, go into a media stream. And so you can imagine in a multi-user conference, you could end up getting multiple media streams, and basically each media stream would correspond to a participant, and then each stream would have a track for audio and a track for video for each participant's audio and video.
Thanks very much. That's interesting stuff. Another question from the moderator stream that we're getting here. This is from Dmitry in Moscow. And the question is, we need a way to save and send recorded video audio via Media Stream Record, which was announced on Google I/O 2012. When will it appear in Chrome? Before we answer that, just one thing I'd like to, just a warning really, that people may have seen on the web blog posts talking about platforms that implement WebRTC, where in fact the platforms have actually only implemented get user media. So there's, of course, more to WebRTC than just get user media. There's the whole actual real-time communication part of that. But going back to the question, maybe Serge, if you could take this one.
Sure, there's been a ton of requests for being able to record media locally from the browser. Unfortunately, the API for media recording isn't fully baked right now, so we're kind of taking a step back and letting the standards process do its thing. When there's a stable draft, we'll start working on implementing that. Right now, we'll be focusing on real-time audio and video going forward.
Okay, thanks very much. Another question that we've had from a lot of developers, going over to a question from Hazrock in Pakistan. Is there any possibility for audio-only communication among peers in future? That is, audio tag can understand remote streams and generated blobs. And I think I'll give this to Malinat, I think.
Yeah. I think that's definitely possible. I mean, you can have two participants having just audio call, and right now we haven't implemented audio tag, but we are in the process of implementing it and providing that feature.
Okay, thanks very much. Another question from Ted at Claudio. He's asking about HTTP streaming fallback. The IETF WebRTC use cases and requirements doc has an F37 requirement stating that the browser must be able to stream data using HTTP. Any idea on how you plan to achieve this?
So, I'll take this one. There are a bunch of techniques that apps today use to work over HTTP, and because most of our sort of communication apps, we run in environments where the firewall is basically locking down everything except HTTP, and we still need to work. And so WebRTC needs to work in this scenario too. And there are a bunch of tricks that can be done to accomplish this. I won't go into all the details, but one easy one is to do HTTP connect, which is kind of the way that SSL is used to connect through like an HTTP proxy. And basically an SSL connection, the data is opaque to the proxy or opaque to whatever's making this connection. And so if we send our data and make it look like HTTPS, then basically we can go through proxies, we can go through things that are restricting to HTTP and HTTPS only. And this is obviously a very important part of of making sure WebRTC can work everywhere. And servers, like turn servers and such, will need to sort of be aware. We'll need to make extensions to the specifications to deal with being able to allocate ports and stuff like that over HTTPS instead of over just vanilla TCP. But this stuff is all, like I said, it's already in use today in various products, and it'll definitely find its way into WebRTC.
Cool, cool. Thanks so much. We've got a question about protocols, actually, but this raised my mind. It's a kind of bigger question about the way signaling works with WebRTC. And one thing about WebRTC is that it doesn't make specifications for signaling methods or signaling protocols. And as I understand it, the kind of name for this architecture has it's been called JSEP. I'm just wondering if one of the people we're with there could just give us a little bit more detail. What is this JSEP thing, and what was the design process that led to that? So kind of some talk about protocols, signaling, and the methods we can use, because I've seen different approaches using XHR and the Channel API Google, or with WebSockets. So yeah, maybe Serge could kick this off.
So JSEP means a JavaScript. God, I always forget the E.
Establishment.
Establishment. Thank you. The JavaScript Establishment Protocol, and it's there basically to it reuses the strength of the browser. The browser browsers are great at communicating over HTTP, and so JSEP reuses that channel for all its signaling. And what JSEP gives us are low-level API that allows us to then encapsulate other protocols on it. So it's really protocol neutral. And so we think that JSEP strikes a good balance for web developers that want to get up and running quickly, and more advanced developers that might want to encapsulate other established voice over IP protocols or create their own more advanced protocols. So it's really a lower level API that allows you to encapsulate other protocols.
Yeah, and we're seeing people do great stuff with this already. That people already have SIP in the browser. There's using something called, SIP NL5. By taking the JSEP API and sort of converting it into SIP. And we've already seen other things where the API can be converted into XMPP. The whole idea behind JSEP is to not bake the signaling protocol in the browser, so that applications can use whatever they need, whether it's SIP, whether it's XMPP, whether it's something custom to the application, and not be constrained by the API. And so far, we're seeing that work out exactly as we had intended.
Cool. Okay, thanks. I just realized we've got about 3 minutes to go. So another couple of quick questions. Again, something I've heard from developers, from Matt in the United States. How is security handled? Could chat sessions be intercepted or accessed by third parties? Maybe Serge?
Well, we've taken the opportunity when designing and proposing this API and the protocols to make sure that encryption was turned on from the very beginning. Encryption for communication peer-to-peer is not an option. It's on by default. And so right now we're at the ITF. There are discussions on what types of encryption and what types of authentication to use, but I think there's strong sentiment to have encryption be on from the start. Maybe Justin can fill in where our implementation is in regards to encryption today.
Right. So we support SRTP, which is a secure RTP in our Chrome implementation right now. And as Serge mentioned, that's going to be the standard. It's going to be required for implementations of WebRTC, and that uses AES and SHA-1, and really, it's state-of-the-art security. And we're also looking at doing something a step further, which is something called DTLS SRTP, which uses the datagram TLS protocol to set up the keys for SRTP, which makes it a lot harder for any sort of man in the middle or anything like that to be able to intercept the keys, because the keys are basically only known by either side, and it provides a little bit more additional guarantee that not only is the media secure, but that the keying and everything like that has been done in a form that's is future safe.
Cool. Okay. And another question we've again had from a lot of developers is just wondering when we might see WebRTC implemented in Chrome for Android.
Android and mobiles in general are extremely interesting for us. As a team, we've decided to iterate on the API spec and help the API get to a 1.0 version using the desktop. So that's really been how we've been executing currently. We've been working on the desktop to be sure that we can provide good, strong feedback to the W3C and the ITF. Now, once we come out of from behind a flag and and the API has reached a stable state, we're going to start cranking on mobile as well. So if you look at code.webrtc.com, you'll see there's a lot of mobile components that are there already. We'll just need to package it all into nice WebRTC for the Chrome browser on Android. But first, desktop.
Yeah, and that brings me to my final question, actually, which is, again, there's a few of these on the moderator. Just if we could just have an overview of where we are now with implementation on the desktop in Chrome and so on.
So as you probably saw a blog post recently about get user media. And so that's the ability to access basic webcam and microphone from the browser, and that's going into Chrome 21. In Chrome 22, we're going to add the ability to remember decisions for secure websites. So if you're on an HTTPS website, you'll be able to always allow certain websites to use camera and microphone, and this is going to make many web app developers very happy, so they don't have to press the allow button all the time. Post that, we've just gotten a new draft from the W3C specifying the WebRTC API. We think that this draft is good enough now to modify our implementation a little bit and try to get that from behind a flag. I don't know exactly where on the Chrome releases we're going to end up, but fairly soon we'll be coming out from behind a flag.
That's fantastic news. Well, thanks very much for joining us. If you'd like to find out more about WebRTC, please look on webrtc.org or take a look. We've now got an introductory article about WebRTC on html5rocks.com. We'll put the links to all that stuff, all those resources on the post for this Hangout and on WebRTC, and we'll tweet that and so on. And yeah, just to apologise for the late start time today. I really apologise for the technical problems we've had with real-time communication. And you know, thank you so much for joining us. And yeah, we hope to be having more Hangouts like this in the future. And just a big thank you to all of the panel today for spending their valuable time with us. So thank you.
I look forward to doing this soon again.
Yeah. So thank you, Justin, Maladat, and Tommy and Serge. It's been fantastic.
It's fun to be here.
Thank you.
Okay.
Bye-bye.
See you guys. Bye-bye.
Bye.